Now let's talk about hypothesis 6. Hypothesis 6 is very similar to this hypothesis over here, except it's in the negative. You cannot actually, in the framework of frequentist inference, we can actually not prove that there is no decrease over time, but at least we can look and see if there is a decrease over time. And if there is a significant decrease over time, then we can at least reject this hypothesis. So we cannot really prove this hypothesis, but there is a chance that we can reject it. So let's look at this. BDI levels do not decrease over time in the control group. So now we only want to focus on the control group. So what I'm going to do is click on Data, select Cases, and I am now going to select the control group only, which is group 1. Select group 1 only. And check that only group 1 is selected. We have the control group, right? So BDI levels do not decrease over time in the control group. So over time, that means that we need to use a repeated measures Anova. So we're going to look at this with Analyze, General Linear Model, repeated measures. Again, we want to keep time with 4 different repetitions. Fine. So I want to remove openness. Not going to have openness as a covariate here. I'm only going to do repeated measures ANOVA with my 4 repetitions over here in the plots. I want to have time here in the horizontal axis with the line chart with error bars that correspond to confidence intervals. I want estimated marginal means as a function of time. And in the options, I want to keep the estimates of fx size. Same thing as before. I'm going to click on OK. First thing I will do is look at Moschli's test of sphericity. It's significant. That means I should use a correction here. So for example, this one, greenhouse Kaiser. In this case, it doesn't really make a difference in terms of what conclusions I'm making, because all tests here are non-significant. So actually, it's important to note, it does not prove that there is no decrease over time in the population, but at least there is no significant decrease, which is different. So there is no significant decrease over time in the control group. And we can also look at the means here. What it looks like, actually, there is maybe a difference between 3 and 4. It's not significant in the pairwise comparisons, however, and again, overall test, the overall F test is here non-significant as well. And the next question is about the same thing, but in the placebo group. So in the placebo group, let's look at it. We are now going to select only placebo group. So I'm going to click on data, select cases. And now I'm going to select the placebo group, which is actually coded as group 3. Continue. Okay. And check again. It's always good practice to check that the filter you're using worked as intended. So here I have the placebo group only. So I'm going to click on Analyze, General Linear Model, Repeated Measures. Keep time with 4 levels. Click on Define. 4 levels are the same, baseline 1 week, 2 weeks, 3 weeks, no covariates, no between subject factors. In the plots, I am going to keep time as the x-axis with a line chart that includes error bars and confidence intervals. Clicking on the estimated marginal means, I want the means as a function of time. And in the options, again, I want to have the estimates of fx size. Let's click on continue. and okay. So the test of sphericity is in this case non-significant, so we can assume sphericity. I will look here at the effect of time, obviously. So again, I'm assuming sphericity. So here I have the f-test. The f-test is non-significant. So that means that there is no significant decrease over time in the placebo group. Once again, it's important to note you cannot here, with this framework at least, prove that there is no decrease over time in the population, but at least you can say that there is no significant decrease over time. So you can retain the possibility that there is actually no decrease over time in the population. But retain this hypothesis does not mean confirm it. Okay, and so we see a fairly flat pattern here of in the evolution of the means in the placebo group. So then we're going to get to hypothesis 8. The decrease in BDI levels over time depends on the group. So this is really, this would be probably the main act, say, in this context. Why? Well, because here, really that's at the core, really that's your experimental effect. What you're expecting to see when you have an intervention like this typically is that in the intervention group, you would have sharper decreases, in this case, of BDI levels as in the other groups. And perhaps in the other groups, you don't have any decrease at all. But this interaction between the group and time is really your experimental effect. So this would really be central in this context in terms of which test to use. This would really be the, the really the central test for the experimental effect itself. So first off, here PDI levels over time depends on the group, so we need all groups for this analysis. So I will remove the filter first. So data, select cases, and I want to keep now all cases. Check that. In my data, if I right click, descriptive statistics, can look at the data that is selected. I have all three groups over here, so that's perfect. Now, I want to, again, study the evolution over time, the function of the group, as moderated by the group, as interacting with the group. All of these are synonyms. So I am going to click on Analyze, General Linear Model, Repeated Measures. And first off, I'm going to keep time with all four levels. Now, it's not asked really here, but we could have an hypothesis that is only, on two of the repetitions, maybe the first one and the second one, a little bit like the one we had over here between the baseline and 1 week. And we could also test that separately. If we had to do that, then we would define time with only 2 repetitions and not 4. But here we're using all 4 because over time is what it really implies, that we're going to use all repetitions. So time with 4 repetitions, all 4 repetitions. I'm going to click on define. So it's already been defined properly. You have baseline 1 week, 2 weeks, 3 weeks. But I'm going to now add group variable as the between subjects factor. Now, I'm going to create a different plot than before. I click on plots. And now you see I have group and time effects. So the overall evolution of time is not really relevant. I'm going to click remove, because now I want to know if the evolution over time depends on the group. So what I will do here is I will look at the effect over time. So time is still going to be my horizontal axis, but I will want to have separate lines for the different groups. So separate lines here for different groups, and I can click on add. A variation we could make both here, is we could get time, say, as the horizontal axis and group in different plots. Maybe that's more readable. Here, that should be readable with only 4 groups, but in the case where you have many groups, it might be easier to just to have a separate graph for each group. And so we're going to keep error bars, even though that may perhaps crowd um, the plot a little bit. So this you could in some cases you could remove it if you think it crowds the plot too much to have the error bars. And click on continue. Then I'm going to look at the estimated marginal means, and this time I'm not going to really display the means over time. I'm actually going to display the means over time for each group separately. And this is essentially what is going to be plotted. I will, if I want to compare, if I want to have comparisons between the different means, I can click here as well. And in the options, I will also keep the estimates of fxi's. Let's click on OK. So now the hypothesis says the decrease in BDI levels, so in other words, the evolution of the time in BDI levels, depends on a group. So in other words, it's another way to say it's moderated by the group, or it interacts with the group. Because the evolution, actually, the effect of time differs by group. So what we're going to be looking at is not really the effect of time, but the interaction between time and group. So here we are looking at the interaction between time and group. In fact, since here we have also a significant test of sphericity, it might be preferable to use one of the corrections, which doesn't really change the conclusion here. So here we see that we have a significant interaction between time and group. So that addresses the hypothesis. It tells us that the decrease in BDI levels over time does depend on the group. So it significantly depends on the group. So in other words, there is an experimental effect. However, it's of course worth checking that it is in the direction that was intended or implied by the design, the research design itself. And of course, what is implied is that in the intervention group, you'd have a sharper decrease. So let's look at that. So we have lots of means over here. So we have means in each group at each time. So what we see is that in the control group, it seems like it's actually even maybe a little bit of an increase. In the intervention group, however, you have quite a sharp decrease, and in the placebo group, doesn't seem to be much change in level. So it seems to go really in the direction intended over here. And so here we have comparisons at each time points. So we asked for that in the options. We have comparisons at each time point between all the different groups. We have control versus intervention and placebo, intervention versus control and placebo, so on and so forth. So we see which ones are significant, which ones are not. We see that, for example, at time 1, we don't have significant differences. We start having significant differences at time 3 between control and intervention, notably in at time 4 between control and intervention, and also between intervention and placebo. Okay, so I'm gonna scroll down. I have here image margin means. I already looked at that. So here we have the comparisons between, so for each group between the different time points instead. So it's a different way of looking at this, right? So here we have comparisons within each time point between groups. And here that's the sort of the other way around. So it's within each group, we have comparisons between each of the time points. And so if we look at the graph, which summarizes really all of these means, we see here the intervention group is in green. So we see actually really a sharper decrease in BDI levels in this intervention group. versus in the control and placebo group, we don't really see much change. If we see any change, we actually see a little bit of an increase here in the control group between time 3 and time 4, even though let's look at this. Time 3 and 4 is actually significant. Um, so the answer to this one is yes. The decrease in BDI levels over time significantly depends on the group, and the test we would cite for that would be the F test for the interaction between time and groups. One of these, because it was a significant sphericity test, we might want to use, for example, this one over here with the F value, use of freedom over here, this one, and then the p-value over here, which is significant. Then let's look at question 9. The decrease in BDI levels over time depends on the group. That's the same thing, really. So there is an experimental effect, it's another way of saying it, but this time we want to control for openness. So it's really going to be very similar, except that now we're going to be able to control for openness. So we're going to click on Analyze, General in our model, Repeated Measures. I'm going to keep this one time with 4 levels. Fine. I'm going to keep my 4 repeated measures over here. They're already defined. I'm going to keep group, but the new thing here is that I'm going to add openness. That's really it. I don't have to change anything, but just as a reminder, I have in my plots, I have time by group. I have the estimated marginal means in which I compare in which I have the interaction of group and time. So I have within each group, I have comparisons between each of the time points, and within each time point, comparisons between each of the groups. And in the options, I've kept the estimates of effect size. I'm going to click on OK. It's important to note that here I am only controlling for openness, even though you see an interaction here with time. That's because it's a repeated measures factor, so it's necessarily there. But we don't have a three-way interaction between time, group, and openness. So there's no three-way interaction here. So in other words, I am here only controlling for openness. And so, which is what expected to do here. So controlling for openness, does the decrease in BDI levels over time depend on the group? So here we look at the same effect. So we have this in our model, but we ignore it. What we look at is the effect of time by group. And so what we see is we still have a significant interaction between time and group, meaning that we still have an experimental effect, even though we controlled for openness. Okay, so the answer can already answer. The decrease in BDI levels over time significantly depends on the group, and so we would use one of these F tests over here, probably a corrected one, maybe the first one, greenhouse Kaiser, over here. We would then look at to see if the effects are in the direction intended, even though it's fairly expected here that it would be, since because of everything we've seen before in this data set. But we can look at the estimated marginal means and see that in the control group we don't have much change in the BDI levels, counting for openness. Same thing for the placebo group, but in the intervention group we actually see a decrease. So it goes in the direction that is intended. Same thing as before, we have comparisons within each time point between the groups. Comparisons within each group between each time point, which is all summarized in this graph over here, which is very similar from the one before. The only nuance here is that we now control for openness in this graph. Okay. So final question, final hypothesis. There is a sharper decrease in BDI levels over time in intervention group than in the placebo group. So here we want to compare the decrease over time, so the change over time, but only between two of the groups, so only between the intervention group and the placebo group. So this time we are thinking, one of the reasons for that is we think that the control group is in fact maybe very different from the treatment group. And so we really want to only compare intervention with placebo, ignoring the control group. So what we would do in this case is we would do the same analysis, except we would um, only select the two groups of interests. By the way, I didn't say that before, but regarding the analysis we've done, so the decrease in BDI levels over time depends on the group. That was a repeated measures one-way ANOVA, one way because we have one group predictor, and repeated measures because we have repeated measures. It's also sometimes called a repeated measures mixed ANOVA. Sometimes it's even called a two-way mixed ANOVA. Mixed means that we have between and within, usually. So there are different names really for the same analysis. I think repeated measures one-way ANOVA is the, or repeated measures mixed ANOVA is perhaps the clearest way of naming it. And this would be the same, but ANCOVA, so repeated measures mixed ANCOVA. So here we're going to, for this last one, do repeated measures mixed ANOVA, except we're only going to focus on the intervention and the placebo group. So the intervention and the placebo group, just as a reminder, they are groups. Oops. They are groups 2 and 3. So we need to ignore group 1. So we're going to click on data, select cases, and we're going to select if condition is satisfied and click on if. And so it's now going to be group is equal to 2 or group is equal to 3. Only going to keep these two groups. I will only keep cases in which group is equal to 2 or group is equal to 3. Click on continue and OK. You can look in the data view over here. And so if we're going to right click on the group and descriptive statistics just to check that we have the intervention and placebo, but not the control group. So all is fine over here. And so we're going to do this last analysis. Click on analyze, general linear model, repeated measures. Keep time with 4 repeated measures. Keep these 4 levels. I'm going to remove the covariate, which is not in the hypothesis over here. There's nothing about controlling for openness. So I'm going to remove openness here. And I'm going to check in the plots that I have time by group with a line chart and error bars. The EM means I want group by time with the comparisons. And in the options, I want the estimates of effect size. So I have a significant test of sphericity, so I should use the corrected versions of the test, which doesn't really change the conclusion here. We would look at the interaction between time and group right here. And so we actually see that there is a significant interaction, which confirms this. So there is a significantly sharper decrease in BDI levels over time in the intervention group than in the placebo group. this doesn't really state in which direction it is, so we would need to look at the estimated marginal means to confirm this. But really what we expect to happen based on what we've seen before, if we look at the intervention group, we see actually we see that in the intervention group we have clearly a decrease over time, versus in the placebo group we don't have much of a decrease or increase over time. And so we can also confirm that with the plot over here, which compares intervention and placebo. In this case, intervention is in blue, and so we see a sharper decrease over here. And so this would be a repeated measures mixed ANOVA, repeated measures one-way ANOVA. So that's it for this comprehensive review of linear modeling and how it is applied to analyzing intervention. I hope this was